Okay. Become a stable thing. I know it's not your fault. You're an inanimate object. Okay. Oh, gosh. Okay. So, the 3 would come down. 3x plus 5 is now to the what power?
Second.
Second power. Times
3.
the derivative of the inside. Okay. We'll stop for a minute. Okay. So I can clean this up a little bit, yes? Of course, I gotta go to the next page. Has everybody got what they want from that? Does everybody think they could do that themselves? Because you're gonna have to on Wednesday. You know I'm gonna give you a problem like this more than likely, right? Just give myself another page. So I got G prime.
Couldn't you have brought the 2 to the front?
I am now.
Okay.
Yes. So now I got G prime equals 8. Two x minus 7 to the third. 3x minus, what was it, plus 5 to the third. Plus, what's the coefficient on the next piece? 9, good, 9. 2x minus 7 to the fourth power, 3x plus 5 squared. Stop for a minute. What I'm about to say doesn't matter, but do you notice how, do you see the powers on the first term add to 6? Do you see the powers on the second term also add to 6? That'll always happen with these polynomial kind of things. Does it really change a damn thing? Nope, just a cool little thing to notice. You don't have to memorize that. Okay, so you guys are like, let me like, why'd you say it then? Oh, it's just an interesting thing. So now if I set this equal to 0, what do I want to do with it? What do I need to do with it, I should say?
Solve for...
Factor it. What'd you say? Oh, divide. It's not a bad idea, but unfortunately it won't help us. But thank you for trying. So what can I take out? Can I take any numbers out? No, it's 8 and 9.
No.
They don't share anything. So how many 2x minus 7s can come out? 3.
3.
How many 3x plus 5s can come out? 2. So then, let me see if you guys cool this. What would I be left with in the first term? I took all of these. I'll be left with 8 times one of these, yes? You guys see that? So I'm going to just write 24x plus 40, because that's what the freak 8 times that is. What about the second term? You have a 9. You'll have one of these left, and we took both of those away, yes? So I'm going to have, good, yeah. 18x.
18x minus 36? Or 63, not 36.
No.
Okay.
63. This look. Okay. So you can see 2 of the answers. Do you remember what we're doing with this, by the way? What are we doing with this?
We're trying to find the tangent line.
Finding where it's horizontal tangent line, which means where the slope is 0, and you see 2 answers already. They're the same 2 things that we got from the beginning for the x-intercepts, right? That will almost always happen. I say almost because it depends on the powers. What about this guy?
Well, you can combine
yeah,
the
you can
terms.
combine. I like it. So 42x minus 23. So let's see if you guys are cool with this. At 18011, you should be able to do this shit. Won't this be 7 halves? Won't this be what? Subtract 5 divided by 3.
Minus 5/3.
Negative 5/3. And then this one, add 23 divided by 42.
Oh.
If you don't like that, just set each one equal to 0 and solve it. You'll get those 3 things. Because how do we make this 0? If any of the individual factors are 0, the whole damn thing is 0.
It's like the 0 property.
Yes, the 0 property rule. I love it. Some books call it the 0 product property. I don't know. It's just if any piece of a multiplication problem is 0, the whole damn thing is 0. That's basically what that says. Stop for a minute. Most of that problem was algebra. And you're all like, I know, man. My algebra's rusty as hell. I know. But the calculus was one step, and the rest of it was algebra, yeah.
So when you said it's a zero, that is
No, that would matter if I needed it on the multiplicity. That would matter, for example, like I said earlier, it's gonna, the derivative would bounce at -5/3, blah, 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 right?
the exponent you're basically saying that
How-
times itself that many times.
Yes, so how many times did 7/2 show up as an answer? 3 times. But it's kind of like, would I add, say 7/2, 7/2, I'm like, you already said 7/2. So I just listed it once. I like it. You guys doing all right? Wide reaction of reactions. Okay, so here's another kind of problem I could ask you to do. So I want to find all the horizontal tangent lines for this.
Chain rule? No. It's not chain rule. Yeah, it is.
So of course, what would the first step be?
Chain rule.
Okay, it's a product rule. You gotta take a derivative, is what you're saying. So again, it's a product rule. So then it'll be derivative of the first guy times the second guy plus the first guy times the derivative of the second guy. Is that cool? Is that all right?
Yeah.
Keep going, math boy. And of course, what do we want to do? That one's kind of nice, to be honest. It looks like it's gonna be worse, but it's better. What do I want to do now?
Factor out an e.
Good. Set it equal to 0, so I want to factor stuff out. So I can take an e to the 2x out.
You probably take 2 out also, right?
No. Yes. I can take a 2 out. I like it. So see if we can handle this. I'll be left with e to the 2x times x squared times -3. No, Jeff. You just took an e to the 2x out. I'm smart. Okay.
We'd be left with
Go back here.
x.
Okay. We'll be left with,
X
this is
squared.
gone. So we'll be left with x squared minus 3. These are gone, plus x. And I want to set that equal to 0.
Why do you think I have 2 e to the 2x instead of just e squared?
There's no e squared in there.
Or e to the 2x?
Oh, just because he happened to notice that this term has a 2 in it and this term has a 2 in it. If you didn't take a 2 out, you would have 2x squared minus 6 plus 2x, and then you could take a 2 out. So it's okay if you don't take a 2 out, you would see it eventually. Yeah. Let me stop for a minute. So when I say, here's a function, find where the horizontal tangent line, where the tangent line is horizontal, it's always the same idea. Derivative, factor, set each piece to 0. So let me ask you this, what makes this 0? What makes this 0? Good, because it's got a, I'm sorry, if you're going to say nothing, you would have been right. I'm sorry. Because it has a horizontal asymptote. The asymptote's 0. You guys with me? The more you know the shape of functions, the
Yes.
easier almost every problem is. So that cannot equal 0. When does this equal to 0? Can you factor it? If I put it in the right order, can you factor that? If you can, show me. Teach me. Because I don't know any factors of 3 that have to be 1. They exist, but are they nice? No. What do I have to do though? Quadratic formula. All right, I don't want to do this. But yeah, just to show an example, there could be a problem that ends up with you needing to do quadratic formula.
No.
Okay.
No.
That's not it.
Oh, that's Pythagorean theorem. You gotta go to the next alphabetical from P to Q. I like that. Yes.
So you're saying what are the answers? It's 2 e to the 2x?
No. When is this equal to 0? Never. So it doesn't give me any answers.
So you're just interested in where it's 0.
Where it's 0, exactly. So the only piece that might give me answers is this one. I'm going to do quadratic for it. I'm not going to do quadratic. I'm just not. I just want to show you an example where the problem could require you to use quadratic. Did anyone want to see the quadratic? It's okay if you do.
So we might get a problem that requires us to use a quadratic on the test. Will we do it?
almost like he's trying to tell you something. I don't know. So x squared, what was it? Plus x minus 3? No.
Minus x, or plus x minus
Jeff,
3.
you just have to do this. X squared plus x minus 3. Alright. What is it?
Negative b
B,
Plus
plus or minus the square root of b
1
squared
squared minus
minus
4ac
4 times a times c
all
over 2a.
So it'd be negative 1 plus or minus square root of 13 over 2. Are those real?
No.
No. Well, yeah.
What happened? I'm sorry. Is everybody alright? It's right there. Oh, okay. It's negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. Are those answers real? I got 2 answers up there, right? Are they real?
No.
Of course they're real.
Well, yeah.
What
but
would have
they're
to
not
be there
good.
for them to not be real?
There has to be a
Nothing.
negative.
You have to have a
Avoid.
root of a negative number. You have to have I. I don't have any I's up there. That would be weird. You're looking at us. It's got the wild dogs. Yeah.
Is he?
No, I'm trying to do it.
You're trying to.
Yes.
Are we in the middle of a pod right now, or can we try it?
No, it's just me goofing around. Sorry. What's up?
Can we try? Because I was.
Oh, I gotta do. Okay, what you got, and then we'll do
Yeah,
implicit.
this on the list. Can you show me how you would do G on the 1G on practice test?
Oh yeah, we gotta do that. Yes.
Yeah.
Okay.
Because I was showing a way to do it. But
So before, we'll eventually get to your thing. There's one idea that I didn't discuss, and if you hit it in the homework, you're like, what the shit do I do with this? This is a really, really nifty idea. Let me see if you guys can go with me down this track. We now know implicit differentiation, which opens the door. And when we learned implicit, we immediately did stuff like inverse trig derivatives. We were not able to do that before we knew implicit. You guys with me? Some of you guys are like, I still don't know implicit, but yeah, okay. So, what if I had to do the derivative of this function? Can I use the rule, the power rule? And no, why not?
Because the power is
The
the ratio.
power is a variable. Power rule requires variable to a number power, yes. Can I use like e to the x? Can I use the exponential rule? No, because that requires the base to be constant with a variable exponent. This dumb thing is both and neither. Yes. So what you do, the main problem with this is I have a variable exponent. The function that helps us with variable exponents is our logarithms. And the log that we use the most often is natural log y. It's got one less letter to write. That's literally one. So we write ln y equals ln x dx. Now, let me stop for a second. Some of you guys are like, oh good, you made it worse. But it went from impossible to still sucks, but then what property can I use?
The
The power can come
power.
in. Now you attack that with implicit differentiation. And it's nowhere near as bad as some of the implicit stuff we've seen. What's the derivative of natural log of stuff?
1 over stuff.
1 over stuff.
Over stuff times derivative.
Derivative of stuff. What rule do I have to use on this side?
Product.
Product rule. Derivative of x is 1 times ln x plus x. What's the derivative of ln x? 1 over x. Neato. So I get 1 over y times y prime equals ln x plus
1.
1. Stop for a minute. So I took an ln, so then I can rewrite it in terms of just everything's flat. Nobody's in a power anymore. Now everything falls into a rule that I know. I have no rule for a variable to a variable. Now I have rules for everything there, including the fact that y is inside because I know implicit differentiation. So then what's y prime? I just have to multiply by y. And y was what again? X to the x.
That's pretty much what I would show.
Oh, okay. There you go. That's how you do it. So if you ever have a function to a function power, you take a natural log first, and then you can do implicit. Now let me see. I'm going to try something real quick. Let me see if I can get you guys. So let me rewrite what we just figured out. Has everybody got what they want from this? Good. I'm going to burn it. Where's my bird? No, I'm joking. Visually, it's going to go. You'll never see it again. No, all right, there. So what I just did was I started with this, and we got this answer. Now, what I'm about to say is not going to mean shit. It's not going to mean shit. I'm going to go a little quick. I just got to show you this once, because I was never shown this. I actually came up with this much later in life. If you were to do this like it was x squared, just go with me for a second. I need you to see. If I were going to do this like it's x to a power, correct?
Mm-hmm.
Wouldn't the power come down times this to the one less? Yes.
Mm-hmm.
This looks weird. Hold on. Come just a little x2. There we go. Okay. Is everybody with me? I'm not allowed to do that. You with me? What I'm doing, what I've done so far is wrong. But if I did that, I would get y. Let's see if you guys are cool with this. What's 1x times x minus 1x's? It's x x's. Okay. So this is wrong. This is wrong. If I were to also look at it wrong as if it was e to the x, or a to the x, or 3 to the x. Does anyone remember how to take the derivative of like 3 to the x?
Bring the power down.
It's, no.
3.
What's the derivative of 3 to the x?
3
to the x
3 to the x times the natural log of 3.
So if I do that here, it would be x to the x times the natural log of the base. Let me see if you guys are with me. If you take this answer and you add this answer, you get that answer. Always. That is trippy. That is so trippy. Why does that seem, I was never shown this. I just sort of was like, wait a minute. So if you look at this in both ways, both as x to a power and as number to an x. If you look at it both ways and just add the shit, you actually get the right answer. That's crazy. When does that work? All the time. Come to find out. If you have no idea what I just did, you're fine. This is all extra shit, yes? The thing you gotta know is how to take the natural log, and then we know implicit so we can do it from there. So if you ever have a function to a function, like a really ugly example of this would be like tangent x to the x squared. You would take the natural log, so the x squared could come down. You guys with me? Then you would do it implicitly. Is that, you guys see what I'm saying? It would work the exact same way. Whatever you say, man. I think the one I gave you on the practice test was x to the secant x. So does anybody want to try that one out? Let's not do that one. Do x to the secant x. Try to do that one. I have this feeling not many people tried that yet. There's Mike.
I was talking to Ryan and I forgot all about leaving.
Wait a minute. I got a class. Anybody else not get their quiz back? Everybody got their quiz back? Okay. Oh my gosh. I don't know much, but I know some calculators. While you guys are doing that, everybody has a practice test that wants one, right? Does anybody need a practice test? Okay.
just times y prime?
Yeah, it would be 3 to the y times natural log of 3 times y prime. Yep. It almost is as easy as anytime you get rid of the y in it, you just tack a y prime on at the end. You gotta be a little more careful than that, but I mean that's basically what most things boil down to.
So about like this, or this question is kind of in relation to the PC 13.5.
Maybe. What's the
So it's you have to figure out. It's like p over q.
Oh, yeah.
P over q minus 1.
Yeah.
I like this one too. But so you said doing that to x to the x is wrong, but since you're doing it to p to the, or not to the x to the p, it's correct because you do x to the p
Because
minus
the
1.
rule works if
P
the
x.
power is a constant. And that problem is saying p is pure constant.
Right. So it works.
Yes, that rule, the shortcut rule works, yes. And that's just showing you the long way to get there, yeah.
Yeah.
Alright guys, let me catch up to you. What's the derivative of natural log of y?
1 over y times y prime.
1 over y by prime. Then this, of course, you have to use product rule. Oh man, I need more room than this. If you guys haven't had to turn your paper over yet, I don't know. Maybe a few times, okay. So y, let me catch up again. Natural log of y equals secant x natural log of x, right? So then you get 1 over y times y prime equals, what's the derivative of secant? Secant x tangent x times natural log plus secant x times 1 over x. So then y prime equals multiplied by y, but what was y? Yeah, y was x to the secant x, yes? So then I can multiply by x to the secant x times all the... It's all the same shit again, yes?
Why didn't you do the prime of 1 over x at the very end of it?
Do it again, sorry.
Why didn't you do the prime of 1 over x?
You mean the derivative of ln?
Yeah.
So if I do times x prime, what is x prime?
Wait, why would you do times x prime? Why don't you just take the prime of 1 over x?
Wait. Was 1 over x inside the function in the first place? No. So chain rule says if you have an inside function that's more than just x, you have to multiply by its derivative, its term. So if I was going to multiply by anything, it would be times x prime. And that's just freaking 1. Yeah, so that's what I was saying before. We do chain rule for everything. When I do the derivative of sine x, it's cosine x times x prime. But of course we know that's 1, so we just kind of pretend it's not really chain rule. Oh yeah, and I wrote that horribly because it's the same shit. Is everybody with me? It's the same shit, just same shit, yes? Same shit. Okay. Now I want somebody to do them in the test. Say something, parentheses, same shit, yes?
What was at the end next to?
It's the same stuff, yes? It's that same stuff. I just multiply both sides by y, which was this. Yes, here.
So you still put the 1 over x at the very end?
Yeah, hold on, I'll do it, guys. You guys don't believe me.
So, what is this called?
So what I did was this, yes, just for room, yes, see? That's what I did there. Is everybody with me? Yes. This is called logarithmic differentiation.
Oh, yeah.
I'm differentiating something using a log to help me. So it's called logarithmic differentiation. Sounds horrendous.
It does.
Got a 2 o'clock appointment for logarithmic differentiation. Worse than a colonoscopy. Okay.
Well, I got.
Yes.
How did the secant x? I mean the 1 over x.
Huh?
1.
What is secant x times 1 over x?
Yeah.
Secant x over x, yes? Because isn't this secant x over 1?
Over 1.
Yeah. Okay.
Well, how come you can't just cancel out the x?
Can't do what?
Cancel the x.
Okay, alright. Granny, you're not alone, but if I have square root of x divided by x, can I cancel out the x's?
Nope.
Because it's inside of a function. So if I have sine x divided by x, does that just equal Symbol.
No, it equals 1.
Okay, good. No, it doesn't equal 1. Oh, the limit does. Be careful.
Limit does, yeah.
But sine x divided by x, I have no idea what it equals. Because I don't know what x is. If you ever have homework or a test or whatever given back to you and there were algebraic mistakes you don't understand what they are, just ask me, right? Trust me. You ask that, you got a lot of people that are going to be really happy you asked that because there are a lot of algebra mistakes happening. Not everybody. And I don't blame you because your brain focuses on the new calculus stuff and then you sort of forget the old algebra stuff where you don't realize when it's just algebra stuff. Okay. Alright guys, what's next? By the way, number 5, it's page 270, right? Not page 267, I said that last time. But just so you know, we're not doing hyperbolic trig functions out of nowhere. We'll do those later.
Or didn't you want to do the 3.5, number 23, I think?
I don't know. Oh, was that yours?
Yeah.
Sorry, Sarah. Let's see, so 3, 5, 23?
I think so. I don't know, you
No,
might
that's
have written
different.
down.
What was it? Oh wait, I
Had it
did have it
written
written down
down.
somewhere. Hold on. I have it somewhere. There. Number 27.
27. I knew it was 27.
Here. Oh shit. Come back. Okay. Alright, so then 27. So this, I'll write this problem down. I still have, understandably, I need you guys to understand what I'm about to say. Implicit differentiation is not easy. But it's also not as difficult as some of you guys appear to think it is. So I have a function times e to the sine x equals x times cosine of the function, right? And I need to find y prime. I need to figure out dy dx. So what rule do I have to use over here?
What question was this one again?
Oh, I'm sorry. 3, 5, number 27.
Product.
Yeah, so go for it. Oh, wait, take the derivative of yes x this side here. Take the derivative of this thing. Yes. Now do it. Still feels really weird doing all that this thing.
This is the third problem, right? There's no fingers.
Oh yeah, down in the page 270 problems. The first few are implicit differentiation problems. I just got tired of making them up, so I just grabbed some from the book.
Just throw y's and x's and play it out.
Alright, let me catch up to you guys. What's the derivative of y? Holy
The
shit.
derivative of y.
And then this guy stays the same. Plus, leave the first dude alone. What's the derivative? What do I have to use for e to the sine x?
Chain rule.
Chain rule. So what's the derivative of e to the stuff?
E to the stuff.
E to the stuff. Times
The stuff.
derivative of sine. Derivative of stuff.
Cosine.
Cosine.
And then you can bring
When is the derivative of a trig function negative?
when
If
it's
it's a co. If it's a co. It's that simple. If it's a co, derivative is negative. Yes? What do I have to use on this side?
product.
What? Okay. Derivative of x is 1 times cosine plus x times derivative of cosine y. I always run out of length. It's amazing. Someday I'll plan ahead.
Sine.
Cosine is negative sine.
Sine y derivative of y.
Okay, so negative sine y times the derivative of y. So I have two sides. That would, is it an ume? What is it? Uma. Thank you. Not an omelet, Jeff. An omelet is my answer. Let me stop for a minute. That is x times cosine stuff. So I know it's product rule. Derivative of x is 1. Sweet. Times cosine y. Plus x is sitting there. Derivative of cosine stuff is negative sine stuff times derivative stuff. There's a little prime on this last two. I don't know if you can see it. Little guy. And now, what do I want to do? Get all the y primes. So this one term, you agreed with me it would be negative x, blah, 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 blah. So I can add it to the other side. All right, that's as far as I'm going to go. I'm going to let you guys. So that's a homework problem. So add this over. What's going to come to the other side? What else is in the wrong place? This doesn't have a y prime in it, so it's in the wrong place. You got to subtract that over, yeah? And then you take a y prime out, and you're 2 steps away.
Wait, how do you get the minus cosine?
No, it's times. Yeah. Let's just keep growing. Yes.
Okay, so I got that far, and then it asks, and then you have to like start plugging stuff in. But because it's a tangent line.
Yeah.
So, and then when you plug stuff in, you get 0 over 0.
0, let's see.
How do you plug it in? You said
0, that would be y. Yeah, maybe so. Solve for y prime to really see what's going to happen. So, no, did you solve
That's
for
what
y
I
prime?
did, yeah.
Yeah.
I got, am I allowed to say?
You got shit. You got cosine y minus y e to the sine x becomes cosine x divided by e to the sine x plus x sine y.
Yes.
Yes.
And then you plug stuff in,
And you get
0 over 0.
ooh. Okay. Did you? Let's see. Okay. So y prime would equal what I just said. Cosine y minus y e to the sine x cosine x all over e to the sine x plus
Wait,
x sine y. What's up?
wait.
What's up?
What?
This is all what I said earlier. Cosine y minus that divided by e sine x plus x sine y. Yes. So you should get 1 minus 0 over 1 plus 0. Should get 1. Yeah. 0, 0 is the point. Yeah. So if you paid attention, I just did a whole problem for you. So I'm not going to show you again.
Okay, I guess I didn't get that.
Paying attention to that.
Wait, how did I not get that?
I don't know. Alright guys, anything else specific or general stuff? Anything from the practice test, from the quiz, from your imagination, from my imagination?
We did this position
Which one? Oh,
for
sure.
switching.
So number 4 in the practice test, I give you this position function, alright?
Oh, I did that one.
So when you see this kind of problem, and you see the questions are, what's the velocity, what's the acceleration, blah, 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 what's the very first thing you should just focus on doing right away? Derivatives. Because what is S prime also known as? Velocity. And what's the derivative of S? Derivative. Negative 3t squared. There's no acceleration yet. Plus 16t. And then the derivative, the second derivative of position, which is the first derivative of velocity, which is also known as the acceleration. Since acceleration is how quickly your velocity changes. We all know this. When we go from a red light, we speed up, we're accelerating. Okay. And what's that derivative? What's that derivative?
The jerk,
What'd you call
right?
it?
What'd you call it?
Oh.
It's okay.
Not that far.
I haven't got to the
Af-
jerk
oh,
yet. The jerk would be
Oh
the
wait,
third.
no, that's after
Yeah.
acceleration.
So if you're on this, it was a train, right? This train apparently has some jerk to it, so it doesn't accelerate smoothly. So it sounds about right. If you've ever ridden on any train in the U.S., it's not exactly as good as Europe, but it's okay. Is everybody with me so far? So I know, they gave me a position function, and I look at the problem, and they say find the velocity, find the blah, blah, and you're like, okay, let me just take some derivatives. Let me find the velocity function, because these idiots, they didn't give it to me, you gotta make it. So now I can answer any damn question. The first few have to be easy. The first one's like the velocity at 3 seconds or something?
3 hours.
3 hours, yeah. What's the velocity at 3 hours? So how do you find that?
You just
Plug it into the
3 hours.
velocity.
You plug in 3 in the velocity, and then I say, what's the velocity at 7 hours? You're like, oh, Jeff, what's happened to your creativity, Jeff? Just plug a 7 in the damn thing, yes? You guys coming with me? Yes.
For E and B, I ended up getting negative answers.
Yeah, totally. So, guys, how do trains work? Even if you've never been on one, it's like the trolley. Does the trolley only ever go in one direction?
No.
It's got to go the other way, or else what's it, you know, that just drive them off in the ocean. We have this giant artificial reef of old trolleys. Like, man, we're really spending a lot of money somewhere. I don't know what to do.
So negatives like in another.
So at some point, the train's going to turn around and go back. Speed can't be negative. If your speed's negative, you're running into a different dimension. I don't know what this is. Velocity can be negative all day, because that would just mean you're going the other way. You've turned around, right? In this case, not turn around, but the train stops, and then the little engineer dude walks to the other side, gets in, and then it starts going, oh shit, right? You with me? Me, I can't sit backwards.
Yep.
Yeah. All right, you stop for a minute.
You're saying B can't be negative?
No, I didn't. I said exactly the opposite. I said
I
exactly
got
the opposite.
negative 35 miles an hour.
I just said exactly the opposite. Some of your answers can be negative because that just means it's after a time when the train is coming back.
Oh, okay.
Poor little train's got to come back. You with me? So if you go up the coast of Seattle, at some point they're going to pick people up and they're going to come back. Right? So if I call this way positive, this way's negative. You guys got it with me? That relates to a problem that says, does it say what time does it turn around? Yeah, at what time the train stops and heads back. What's going to be true when the train stops?
0.
What's 0? Velocity 0. Just say velocity equal to 0. Yeah. Now, what do you think my favorite question is in that problem? The last one. How fast the train is going half an hour before it gets back to where it started.
Oh gosh.
Screw you, Jeff. So when does T? When do I start? What's T when I start? Makes sense.
0.
No time has passed. Where am I at when T is 0? Where am I at when T is 0?
At the start.
I'm at exactly where?
The station.
Plug a 0 in. Plug a 0 in.
That's 0.
You get 0. I'm at position 0 at time 0. Yes?
Yes.
So now I'm saying half an hour before I get back. Okay, well what would it mean to get back? I would need my position to be
Negative.
no.
0.
0 again. 0 is where I start, correct? I'm going to go away from that and then I'm going to come back to it. So if I set my position equal to 0, I can see at what times that's true. So what do you get when you set the position equal to 0? How do you solve something equal to 0? Factor the damn thing. So what comes out? Sure, t squared. You get negative t plus 8. So one answer, of course, is t equals 0. We know we're home when t is 0. That's where everything starts. When else am I back home? If t is 8. Which, funnily enough, is where this stops. So this is like one complete journey for this train up to Seattle and back. Don't come at me with 8 hours. It's like a fast train. They got fast train. Half an hour before that. So what time am I talking about? 7.5 hours, right? If it takes 8 hours for it to get back, and I'm talking about half an hour before that, I'm talking about 7.5 hours. Now what's the real question, ask me?
What's the position at 7.5 hours?
Try again.
What's the speed?
How fast the train is going a half hour before it gets back. It gets back 8 hours later. Half an hour before that is 7.5 hours later. And now I just got to plug a 7.5 into velocity. just to make this weird ass math dude happy. So now it's coming back, it should have a negative velocity, right? If you stop and think about it, it doesn't go to 0. The velocity is 0 at 2 locations. Anyway, I'm not going to overanalyze this thing. Don't think too much about my train. At some points it could be going insanely fast. I don't know, I didn't pay that much attention, so don't overanalyze it. Oh yeah. Oh yeah. I don't know
Never slows
how
down.
fast is it going?
Train that never slows down.
64 mile an hour?
You gotta jump on.
I hope not.
Never stops.
Everybody get ready? Alright, sorry. All that's beside. Okay. Yes.
How about 1F for the practice test?
1F. Ooh, yeah. Okay, perfect.
Oh, yeah.
Somebody remind me that we already did this. If I have natural log of x squared, how can I rewrite that? 2 natural log x. Does anyone remember the thing I said? I've said it a couple times, and I'm trying to make a big deal out of it. If I ask you to do calculus to a function, you first simplify the damn function, yes? So the function I gave you on 1F is this evil little monster here. That's a chain within a chain within an exponential. Oh my God, Jeff, what's your problem? Who hurt you?
Okay.
But
I'm fine with it.
so I must have. What can I do instead of that shit? What can I do? What can come down?
The sine.
Stupid sine can come down.
5x.
Stupid
minus 3.
sine. So I get, Jeff. I get sine of 5x minus 3 times 2 natural log of 3. Look at that. That has suddenly become, it went from chain inside of exponential, inside of chain, it went from that to, I need you to understand, a constant multiplier of freaking sine. Just one
It's
chain.
just gonna be-
Yes?
Is that what you do every time you have like something to the power?
That's what I would do. You can do whatever you want. Yes.
Isn't it just gonna be 0?
Huh?
Isn't it just gonna be 0?
No. So, let me rewrite this again.
Because you have the derivative of whatever times 0. Because
No. You can't do all the derivatives at once. 0 degree, that's a constant. 2ln 3 is
Yes.
a constant. So leave it alone. It comes for the ride. So what am I taking the derivative of first? Sine. Constant times sine of stuff, the derivative would be constant times cosine stuff. Times
Stuff.
derivative of stuff. Yeah. I need you to understand how horrendous this would be. That would be unbelievably gross. And some of you guys are like, yeah, I lived that shit, you jackass. I'm like, I'm sorry. It's too bad. Just gotta think for a second. So if I ever see inside of a log something to a power, I can take that power down. We just used that fact earlier. When it's got ln of x to the x, I can take the x down. Yes. So again, if you're simplifying a function, what does that mean? What I've written is equivalent to what it began as. The derivative of the new thing is the same as the derivative of the old thing, right? But the new thing kicks so much ass. Its derivative is so easy.
I actually really like that problem.
Huh?
I actually really like that problem. It's a really nice problem, but it tries to screw with you at 2 points.
Yes. Which you mean, I made it, so I guess you can just say I'm trying to screw with you. So what about 1e? What's the right way to look at 1e? Do you attack the quotient rule?
You can do, yeah, factor first.
Let me show you a little trick. What is it, 3x squared? Was it?
Minus 14.
Minus 14x plus 8 over x minus 4. Minus 4. Alright, now listen. What's the only way that factoring this will actually make a difference? I don't have to do quotient. There's only one thing that must happen.
If you can get the x minus 4.
X minus 4 must be a factor of the top. So just assume x minus 4 is a factor of the top. And if it turns out it isn't, I'll just go back and do quotient rule. So I don't know if you guys have ever seen this. X times what is 3x squared?
3x.
3x. Negative 4 times what is positive 8?
Negative 2.
And what do I get? Negative 12 minus 2, negative 14. Now I can do the derivative of 3x minus 2. When I have a hint, factoring is easy. Now, you know me, I could make it so it doesn't work, and then you just have to do quotient. Well, who cares? If I'm you, I'm going to try the damn thing, because if it works, that can, what's the derivative of that? What's the derivative of that?
3.
Frickin' 3. Yes? Now you could do quotient rule on all this, and if you do all the simplification you can, it will come out to be 3. And you should think to yourself, there might have been an easier way. Oh, well. So again, I need you to understand. Just take a moment. If you can't see how to simplify a function, great. Attack it with whatever you can think of. But just take a moment and go, can I simplify this somehow? Can I take a power down? Can I factor and kill something? Right? Okay, maybe. Yes? Sure. Alright, let me make a function you actually have to use quotient.
About no. I guess I don't teach. That's just devices, but
No, that is quotient rule, yeah. So we can do that one if you want to. Let's go 3 sine x. Plus 2x over 2 cosine x minus 3x. Okay. Now, dear God, can the x's cancel? No. No. Can the 2's cancel? Same reason for the no, right? You cannot break into an addition subtraction problem with division. That's not a power division has. Division can only cancel multiplication, and I have a plus and a minus in the bottom, so that's not going to work. Okay, so therefore, I can't simplify this. I can't factor anything, so I just have to start quotient rule. Good. What's the, does anybody remember all the words to the song?
Top first.
The song is top first. Yes. So you take the derivative of the top
Nobody high, high, low,
times the
over
bottom
the square of what's below.
The top
minus the top.
times the derivative of the bottom.
Damn it, Jeff, you're never going to learn, are you? Times the derivative of the bottom.
Yep.
Square.
Over the bottom square.
That's just bad. Here. Just go away. All of you. Got it? No. This one. Okay, let's try this one.
Oh.
This is where the first app I used was better. It just gives me infinite white space. But okay, let's try this again. So I got the derivative of the top times the bottom minus the top. Still good about that. Times the derivative of the bottom. All over the bottom square. Yes. Now, if I remember correctly, a couple of interesting things happened. What's the derivative of 3 sine x plus 2x?
3 cosine x.
3 cosine x plus 2. I like it. So ready with me? So in the interest of my space, has everybody got that? What I've written so far? Let's see if you guys are cool with this. So this will be 3 cosine x plus 2. What's the derivative of 2 cosine x minus 3x? Good. Negative 2 sine x minus 3. And now what do you do? We take that prime away. Go away. All right. Now what stage are you at? I'll be a little more specific. Yeah, foil. Foil. Get all your electrons together. In general, do you see how you're going to get a cosine squared term? Do you see how you're going to get a sine squared term on the other side? Whenever you see that, you're trying to see can they come together to make one somehow. So let me ask you this, and I got this on the answer piece, I don't care. What is sine squared x plus cosine squared x? That's insane. What is sine squared theta plus cosine squared t? Good. I don't know. Okay. Beautiful, because they're not the same angle. So the idea is they have to be the same angle, or else they can get whatever the shit it wants to be. I don't know. So what is 3 sine squared x plus 3 cosine squared x? It's freaking 3. So if you see, I don't know, 6 cosine squared x plus 6 sine squared x, that's 6. Isn't that 6 times cosine squared x plus sine squared x? So 6 times 1. You guys see that?
Yeah, you can factor out 3 or factor
Yeah,
out 6.
exactly. And then you uncover the basic Pythagorean identity. Good. And you keep the old Greek dudes mentally alive. Okay. So vampire artist. I'm still alive. Okay. It's very strange. Is that? I don't know. I didn't want to feel like doing all this because. But you foil, then you do it all again. And then you get your like terms together and you look for your sine squared and cosine squared, see if they go together. To use that identity. Yes? Okay. Okay. So you know you're going to have a problem where you have to use quotient rule. You know you're probably going to have a problem where you don't have to. You can actually simplify it. But if you don't notice you can simplify it, you can still use quotient rule, right? You know I'm going to ask you a problem where I'm saying find out where the tangent line is horizontal. Because I need to see if you get back and that kind of stuff. Yes, yes.
What about number 6? What is practice test?
Oh yeah. So did anybody try number 6?
Yeah.
Okay. So let me just do this for myself. Let me show off all my math skills. So if I do this in the calculator, if you do this on the calculator, you should get something that looks roughly like this. See if I can figure this out. 1 is -2. And then it turns there. This has an end behavior of that. So it should look roughly like this. Very roughly like that. Maybe?
Yep.
That's power of pre-calculus. Okay. Sorry. So now all I'm asking you to do is like section 2.8. Graph the derivative of it. So anybody remember the first thing you should plot when you're about to graph the derivative? Yeah. Where does it look as if the tangent line is horizontal, where it's got a 0 slope?
At the origin.
Good, at the origin.
And it's
Somewhere in here.
there.
So if you graph it in calculator, you can probably get that better. Huh? Is it 2? Very close, I think. You can do it, Jeff. I don't know. I'm not gonna work close. Now, is it what's happening back here? What's true about the slope? Look at this. Can you guys tell? Wait a minute. Let me try something. Where do I see it? Do it, Jeff. Where are you? There you are. What's happening back here? What's happening back here?
It's increasing.
Good. The slope is positive. So, where should my graph of the slope go then? Back there. It should be up here. What's the slope? Isn't the slope positive, getting smaller?
Yeah.
So it's positive, getting smaller, and then what happens at 0? What happens once it goes through 0? Now it's
negative.
Negative slope. Until it gets to here where it's 0. So it's negative slope, and then it's 0, and then after that it's positive slope. Yeah, so just like we think, it's got a little hitch in it. That's okay because we're doing it by hand. I would expect to get from a cubic, I would expect the derivative to be parabolic. Yes? Yeah, like
One less than.
you lose power. Yes?
Is it your graph saying that the slope got positive again for everything?
Of course it did, because right after this point it's going up now. Yes? It's only going down between here and here, yes? That's the only place where it's negative.
Yeah. So why?
Once it gets past this point, it's going up.
Well, I see it's going up before that.
This point right here. Alright, I got a lot on here. Take some of this. Well, what you want to do is you want no, it's like a football play. Alright, got it.
Switch colors and trace it.
Yeah, it's, you know, I was a good teacher. Alright, that's got a lot less spaghetti on it.
Quick question, Professor. If I need to
Sure.
come up with an answer key for the practice test.
I've got it, yes. Let me see. What is that? Is it the highlighter? Oh, that's gross. Okay. Do I have more colors? I do. What is that? Okay. So right here, it's got a slope of 0, correct?
Yes.
Okay.
Oh, it's because the slope is really.
So the slope, stop it. The slope is positive here. So I'm up here, and then it approaches 0. Then it's negative between these two red points. Somewhere in here it gets the most negative, and then it goes back to 0. It's less negative as you go around the bend. It's less negative, and then after that it's positive forever.
So it gets less negative, you curve it up.
No. Well, sort. Okay. So
Is that
it's
true?
definitely negative through here, yes.
Yeah.
And my outputs for my derivative are negative.
Yes.
Now somewhere here it's the most negative, and then it goes to be 0 here, so it's got to be like that,
Less negative.
and the less
It's
negative.
got to be able to go back to
See how it's approaching, it's getting less negative slope? The slope is getting less negative until it's 0. And the minute past the 0, it's now going
Continually increasing.
up. It's now increasing, so my slope graph better be in the positive part, because the slope is positive. Tell me something about the slope right here.
Yeah, that is
It's
positive.
positive, so when I graph the value of the slope, it better be positive.
Yeah, so
Yeah.
it's just like looking at before the point where it's 0, right?
Yes.
The point. So for the graph of the derivative, you can see that it's still like, shouldn't it still be negative?
It
It's
is.
just getting less negative.
The value.
Oh, no.
The value.
You're looking at the slope of the line I drew, which is not correct. Isn't every value on this negative?
Just like this.
Just less negative than it was before. You're looking at the slope of the slope, which is not what I want you to do yet. Later we'll look at the slope of the
So
slope.
at the beginning, it comes from the top because that's the biggest the slope can be, or it's coming from.
Yeah, it's big
Very
ass
large
positive
slope.
here, big ass positive.
Getting
Then it's
smaller.
getting less positive until it's
Yeah.
0. Then it's negative. And then it gets less negative, and then it's 0, and then it's positive. And again, parabolic like we expect a cubic to become after one derivative. Yeah.
What about, like, for that type of problem, would you ask us y equals x to the 4th times blah blah blah? So like x to the 4th instead of x. You factored out an x step.
Yeah, I did that so I can graph it by hand quickly.
Yeah. But
So I can
like,
see the x-intercepts.
would you ask us for x to the 4th?
Why not?
So can you show us an example?
No, especially because this problem, I said graph it on your damn calculator, right? Then you just had to copy it down. Not a big deal. On the actual test, I'm going to give you a function, a graph. You with me? So I'm going to give you something like this. Where's my just normal blue? Damn it all. There you are. Stop. Yeah, go away. So I'm going to give you, no. Ooh, it's even better. I'm going to give you something like this. And I'm going to say on top of that, graph, so this is F. And I'm going to say on top of that, graph F prime. So where do you guys start?
at the top because it's negative, because it's going positive.
That's the highest.
No. Where's the first thing to plot?
Oh, the zero.
Where the slope is
Zero.
0. So the slope is 0 about right here. 0 about right there. 0 about right there. You guys with me?
Yeah.
Alright, so now I got my anchors. What's true about the slope back here?
Positive.
Very large. Positive.
Positive. And then it's getting closer to
Getting
0,
lesser and
yes?
lesser.
So it's positive, getting smaller. Okay, that's a little bit freaky, but too bad, Jeff. Go on. Until it gets in here. Now, what is it after this? What is it now?
Now it's going negative.
Now it's negative, getting more negative, correct? Until about right here. Do you guys see that? Right there, it's about the most negative slope. Because the minute I get past that, what's the slope doing?
Increasing.
It's getting less negative.
To 0.
So as I graph the derivative, the value of the slope should be where I am. This value of the slope right here is negative something. The value of the slope over here is less negative until I'm at 0 here. And now what's the slope doing here?
Increasing.
Now it's positive. Somewhere in here it looks to be the most positive. So about right here is going to be the most positive. And then the slope is getting
Negative.
less positive. And then it gets to here. And now what's the slope doing?
And now it's going negative.
Holy shit! So if you look at my graph, it's a cubic. And the original graph was a 4th power. And again, that's what you expect. A 4th power's derivative should become a cube.
Yeah, that's what I was asking.
Now this is one of the harder things to do, because your brain keeps trying to take over and says, just follow. No, brain, stop. I got to think about the slope. If the slope is positive, it'll be up here. If the slope is negative, it'll be down here. Yes? Otherwise, you just sort of start following. Follow the graph. No.
Yeah, that was what I was asking for. So,
Okay.
yeah.
You're welcome.
Return this letter.
No? Yes.
So you're just gonna look, like if we have this question, you look for like the trend, basically. You wanna look
Sure.
for accuracy.
So this function is trending upwards, but then it's trending upwards with smaller slopes. So my values of the slope are getting smaller until it's got a value of 0, and now it's got values, negative values. Yes? Yeah. Running out of ways to say that. Yes?
So it doesn't need to be 100% perfect.
Of course not. Hell no. Is this low as low as it's supposed to be? I don't know. I'm doing this by hand. I just needed to make calculus sense. If the slope is negative, you better be down here. If it's positive, you better be up there. If it's 0, you better be on the x-axis. Okay. Right? I just need those generalizations to be true. Okay. Anything else? I don't know if people believe me when I say I brought nothing. It's all based on what you guys got. Yes?
Can you go over, I think it's 89, but it's 5. It's in the book.
89. Oh, from the practice test?
Yeah.
Oh, yeah. Okay. Oh, yeah. This is an awesome question. Okay. Of course I like this question. So the question says, find the equation of a parabola. So they say, hey guys, remember this is a parabola. Where the slope is, you're not going to remember this, Jeff. Passes through the point 1, 4. And it's got a slope of 6 at x equal -1. And a slope of -2 at x equal to 5. So let me ask you this. How many pieces of information did they give me? 3. Good. It goes through that point with a slope of that there and a slope of that there. Why does it make sense? Because how many things do I not know? 3. A, B, C. So in mathematics, if I don't know 3 things, they better give me 3 distinct pieces of information. Kind of feels like a murder mystery. I got all this shit I don't know, so what am I trying to do? Get as much information. How much information? In mathematics, it's nice because it's exactly equal to how many things I don't know. Now the question is, how do you use that shit? Can somebody tell me the fact that this goes through 1, 4? What does that mean? It goes through 1, 4. What does that mean? So let's say it a different way. When I plug a 1 in, I better get a 4 out. So what do I get when I plug a 1 in?
Better get a 4 out.
From the function. I appreciate that though. I'm going to show this guy I'm listening. So what do you get when you plug a 1 into this?
A plus B plus C.
A plus B plus C. And that's supposed to be? 4. Okay, so we know one piece of information. Does this look familiar? For pre-calc? Systems of equations? So how do I do this? How do I use this other information? Slope is 6 at -1. What do I have to figure out?
Now you do these two.
So you,
No.
you know, you plug
Yeah,
one
right
and
triangle.
make the
It's got A, B, and C. I'll give you that. But it ain't got a right triangle. So no. Slope is 6. So what do I have to do to this function?
plug a 6.
No way. So if I take the derivative, what do I get?
2ax plus b.
Now, real quick, side note. Do you guys remember the shortcut to get the vertex from pre-calculus? I'll get it started. X equals -b over 2a.
Over 2.
Negative b over 2a. That's how you found the vertex of a parabola. You plug negative b and a, the negative b over 2a. When does the vertex happen? We know when the vertex of a parabola happens in calculus. It happens when the slope is 0. If you set that equal to 0, you'll get negative b over 2a. Don't you get negative b over 2a if you set that equal to 0?
Mm-hmm.
That hits a little different when so many people forgot negative b over 2a. It's true. But hopefully maybe that'll come back to you. What's that? What I just said? No, that was just me pointing out the calculus way to get something that took a long time to get before. Oh shit, yeah. Okay. So now, how do I get this? What do I do with this? I'll tell you what to do with that, Jeff.
1 equals
Yes.
6.
So when I plug a -1 in, it's a -1. I'm supposed to get 6. And when I plug a -2 in, no, I'm sorry. When I plug a 5 in,
5 in, you're supposed to get
Should get
-2.
-2.
I get -2. Pretend like that's what that is. I know, it's like music now. What class are we in? I don't know. Definitely not. I would be sitting out there. Okay. Now, couldn't you solve one of these equations for B? Couldn't you plug that information in there? When you just had A's then? Hey, that would be nice, Jeff. No, just A's in your equation. Do you guys see that? Do you guys remember how to solve systems of equations? One way to do it is substitution. If you solve this for B, plug it in, you'll have A's, you can solve for A. Once you know A, you'll know B. Once you know A and B,
I know those
you can find out C. Yeah. So it's just 3 pieces of information. Can you use them correctly to figure out the 3 things you don't know? That's the point of that problem. Okay, I like it. In case you forgot, 101 and 105 are going to be on the next test. That's the section 3.9 that we haven't made it to yet. Anything else? What we discuss is up to you. Keep it math though, yes.
Go over 3.3 questions, 49, and like those types of questions.
the limits of trig.
49. Oh, okay. So just to talk about the kind of problem I would give you. So what I desperately need you all to know, I need you to know this truth. What is that?
1.
Sine 1. Right, we actually use this to prove the derivative of sine. And then this is just a fact in its own right. So what all this little section of problems does is just kind of plays around with this. So the main idea of this statement is the limit as the angle goes to 0 of sine angle over angle is 1. So the thing that students don't quite understand at first is if my angle inside is 5x, I can't, in the bottom is x, I can't apply the idea yet. What must the bottom be? 5x. If I'm missing a 5, now this is going to become very important in the second half of calculus. Don't I want a 5 right there?
Yeah.
Damn it, can I just put it there? No, because then I've changed the problem. But I can put it there if I balance it out.
5 over 5.
No, so if I put a 5
So you.
and a 5, what's the limit of this?
1.
1. So 1 times 5?
5.
That's crazy.
Okay, you're just multiplying by 1.
Real quick, what was the first problem on the last test? It was tangent of 9x over something, I can't remember, 5x or something.
Test 1? Or the quiz?
Maybe it was the last test. I think it was, or was it? No, it was the test. It was, Jeff, just look at it. I don't know if I have it here somewhere now. Damn it. But it was something like this.
You got limit x to 0 with 7x over tangent 5x.
Beautiful, I love it. Okay, that's perfect, thanks Dave. What's tangent?
Sine and cosine.
Good, so I can rewrite this and see if you guys are cool with this. I can rewrite this as this. You guys all cool with that?
Well, like cotangent?
Oh, because it's 1 over
It's
tangent?
1 over tangent.
So you flip it.
So yeah, it's cotangent, which is cosine over sine. Is that cool? What do you wish was here instead of 7?
5.
5. So let's look at this. So I get the limit, x goes to 0, of, we just put 7x over sine 5x times cosine x. Is that cool? I didn't do much there, right? So good job, John. I don't want a 7 here, so let me take a 7 out. What do I want there?
A 5.
A 5. So if I put a 5 here, I better have a 5 here. So I just didn't change anything, correct?
Mm-hmm.
Yes, sir.
Isn't it supposed to be sine over cosine?
Sure, but it also works the other way. Now in this test, you didn't have to know that, because this you just make a table and investigate. You didn't know the shortcut. Now I know the shortcut. So if you had this problem on your test, let's see what you're supposed to get. See how I can take that 5 out? Is that cool?
Mm-hmm.
So you get 7/5. Now what's the limit of this?
1.
1. And what's the limit of cosine as x goes to 0?
1.
1. So do I get 7/5 or 1.4? Does that look familiar to about 1/4 of you? Or 1/2? I can't remember how many versions I made. 1/2 of you. Did anybody get 1.4 in the last test, the first problem?
Probably.
You didn't get 1.4, you got it wrong. If you had this problem, by the way, if you had 9x and bullshit, then you're not going to get this. It's a different number, but you can do the same thing I just did. Did you have to know this on the test? No, you did it with a table. But I can do it without a table. I can just kind of use this fact. Let me stop for a minute. This problem looks like one of the problems in that little section. You have to rewrite tangent with sine and cosine.
So how did you go from the step of 7x over sine 5x to
I took the 7 out of the way, and I put a 5 there. The only way to legally put a 5 on the top was to put a 5 on the bottom. See that? Why do I need a 5 up top? Because the angle is 5x. And in order for the limit to be 1, the angle has to be the same.
Technically, we pulled the 1 over 5 out as well.
Yep.
Let's multiply that by our 7 instead of.
Yes, I love it. So again, you didn't have to do this. Thankfully, nobody did this because then I'm like, you don't know this yet. What are you doing? Okay. Now, real quick. This is not that big of a deal. It really isn't a huge deal. The limit of sine x over x is 1. It's not like the be-all, end-all. Okay. Anything else?
3.557.
3.557. Oh, okay. Let me put this up here. This one?
Yeah.
going to let you guys ponder that for a moment. I'm going to go ahead and give out the answer key for the practice test. There's 2 pages to it, so what I give you is yours.
Oh, okay.
No, it's yours. It's all yours. 2 pages. All yours. 2 pages. Everybody got answer key? All right.
Number 8.
Yes, I will. I'm going to say one thing about 57. I'm not going to do it. It'll take a little while. It's homework, and this is kind of like what I would consider a bonus question, really. So I just wanted to push you a little bit. There's a little bit in there where you have to plug stuff back in. It gets a little bit weird. So I can answer specific questions individually about 57. We're not gonna have a problem like 57 on the test. Okay? You with me? Huh? Oh, hell yeah.
Can we do 62 then?
Huh?
Can we do 62?
62. Look at my cuties. Oh yeah, by the way, orthogonal just is another word for perpendicular. Believe it or not, we have like at least 3 standard usage words for the same frickin' idea. Okay.
Normal?
Ortho, normal, orthogonal, and perpendicular, yes. Yeah, math people, we're special. Okay. What did you say, 62?
Yeah.
Okay, now let's a little bit more normal, I guess. Say the stupid joke.
So,
Ooh, I like this problem. So, and somebody remind me, what's normal line mean? How does it relate to tangent line?
Perpendicular.
Perpendicular. I like it. So, if you want to find a normal line, pretend like you're finding a tangent line and just take the negative reciprocal of the slope. Yes? What method of differentiation do I have to use? Implicit. You could solve for y, but I highly suggest you don't. That would be really gross. Coefficients would be functions of x. You don't want to do that shit. So I just use implicit differentiation.
and once you get
the normal line, how do you tell when any function intersects another function?
set them equal to each
Set
other?
them equal to each other, yeah. And a shortcut for that, let's see. When you get the equation of the line, once you get y equals the function of x, once you get like y equals x plus 7 or something, Can't you just plug x plus 7 in? That's another way to set them equal, is to just plug one into the other one. That's a little hint from me to you about how to solve that.
So you said.
Once you get the equation, the normal line.
Is it opposite reciprocal? No.
Negative reciprocal.
Yeah.
Yes. Change it as much as you can. Reciprocate it, and change the sign. Yeah.
You probably won't want to do it, but how would you set it equal to each other?
Oh, so the shortcut way to do it, especially when you have a function like this where you can't disentangle the x and the y. In order to set two things equal, what I really mean is they both have to be the same value at the same time, correct? So that means whatever the y equals in one, it's got to equal that. It's got to equal that in the other one. So if I get a normal line of like x plus 2, y equals x plus 2, I can then plug an x plus 2 in. Do you see how then you're going to have a function with only x in it? Can't you solve that then? Okay. To get the x values, yes. Okay.
So wait, so then in this one are we solving for x or y? Does it matter?
Yes.
Well, because if you do that, then you're just gonna see if they equal each other, and you're not gonna see.
No. Okay. How far have you got?
This
Do you
far?
have the normal line? What's your normal line? Okay. Now plug that in for y into your original equation.
Oh. Okay.
Yeah, that problem, I don't know. That's a little bit of a push. It's really not that bad. What was it? Whatever, Jeff. Anything else?
Number 8, the practice test. Oh,
8?
8.
Oh, number 8 on that one
5.
section. Okay, I got you.
Yeah, that's what
I'm with you. Page 270, everybody. Page 270. Number 8. Oh. Oh, look at that. We got schmooch in my nail. Oh, too bad for everybody.
Oh, that's not the one.
Which one did you mean?
Take 25, it's the one after that.
Okay.
Ooh, some chain rule.
Yes, good. So this is the sign of stuff. So it's primarily a chain rule, yes. Yeah. And then some of you guys notice that this itself will eventually be a product rule. So the way I highly recommend doing this is, what's the derivative of sine stuff? Cosine xy times xy prime. Don't have so much in your head at once. Just write the rule down. Worry about the specific derivative on the next line. Yes? This,
and that's just
let this be easy, dear God.
2x.
2x minus y prime. No. And now you have to solve for y prime, all that kind of business. Is that all right? Here's something, it doesn't really apply to this unless it depends on. If I have a problem, look at number 31. Let me pick a better one. Here we go. Look at number 32. Which part of that is an angle? There's two parts of that that are angles, yes? Can somebody give me one angle at number 32? No, one angle. I want an angle. X is an angle. I love it. How do you know X is an angle?
Because it's
inside freaking cosine. What's the other angle?
E to the x.
Good. So when you take a derivative of this guy, the angle cannot change. The inside does not change. You guys with me? So if I take the cosine of e to the x, it becomes negative sine of e to the x times the derivative of the inside. The inside will not change. When you take a derivative of a function of stuff, the stuff doesn't change. That's why I like to say stuff. What's the derivative of e to the stuff? E to the stuff times derivative of stuff. The stuff that it doesn't change when it's still inside the function. Look at number 36. That looks like a problem I could give you. Somebody. I just saw somebody go like this.
know it's working.
Go ahead and give it to me, Jeff. Do you want to just do it the way it's written?
No.
I don't want to do it either. So, how would you rewrite, at least one thing, you would rewrite the radical as 1/2 power. You could either leave it the whole thing to 1/2 power, or you could make it t to the 1/2 natural log to the 1/2, yes? What about the t to the 4th inside the natural log? What could you do? Bring the 4 down, exactly. So you don't have another chain rule inside of a chain rule. Do you guys see that? Look for your natural logs because they have a ton of properties that allow you to simplify them. On that note, Jeff, what about the difference between this dude and this dude? Is there a difference?
Yes.
What's being raised to the 4th power in the first one?
Just the X.
What's being raised to the 4th power in the second one?
The whole thing.
Does the property of logs work on both? No. Which one does the property of logs work on? First one. When the power's on the argument, it can come out front. And this derivative kicks a lot of ass, right? Little smiley face. Very crazy. Okay. This guy that I'm pointing at, which you guys can see when I do that, this guy, much grosser. Not like really crazy gross, but compared to this guy, a lot grosser. I can't do shit with that 4th power. Power rule is fundamentally it's the stuff to the 4th power. How do I take the derivative of stuff to the 4th power?
4
times
stuff.
Stuff.
Times stuff's derivative.
No, to the 3rd power. So some of you guys forgot to change the power. You gotta be careful. Times
the derivative of
stuff. So you get 4 ln of x to the 3rd times 1 over x. If you leave it at x, it's okay, but you can put it all over x. Yes.
Still 36?
No, this is just the problem I just made up. Okay. Yeah. Yes.
Usually we notate like the first part of it, like 4 ln 3x, like in between 3's, in between the ln and x, like we do a trig function.
Oh, this one?
Or like, could you move the x1 on the right, the x1 and 3, like on
Here.
the row that way, like you would write
Oh.
secant squared x, you write like ln.
If you had existed about 357 years ago, you could have maybe argued for that. They could have maybe said, sounds good, but no, we don't do that.
Okay.
It's the same idea though. I agree with you, but we just don't do that.
Okay.
That would be silly. It's just as dumb as putting the 3 on the side, to be honest. But this doesn't happen often enough. I think that's why. We just don't see a lot of logs being raised to their own power. But so when they do, they're just writing it like that. We don't put the little 3 on the ln because that would get confusing. Sort of like if I ever did, this, that would get confused. Well, that's exactly. If I gave you this, what is this really?
Sign it.
So I'd rewrite it like this immediately if I were you. So then you look at it the right way. Yes? Okay, maybe. Okay.
What about looking at it the other way, for sine 4?
Do it again.
Well, isn't there like a different variation of sine 4 to the x?
If I have sine of x to the 4th, maybe, you mean this?
Yeah.
See how that's different from this? What's being raised to the 4th power here?
The x.
What's being raised to the 4th power here?
Sine.
Sine x.
Oh.
Yeah. One reason I don't like this notation is because it makes you guys think that sine is its own thing. Sine is not its own thing. It has to be of something. So, the little bit of time we save from doing this, I don't know if it's really worth it. But we just did it. Oh well. The guy in the back was about to say something about natural log, and he passed it. They passed away a lot. He was 33. Okay. I got nothing, guys. It's based on what your questions are.
Second 3.5, question
3.5 number who?
47.
47.
Find a point from the infinity symbol from exercise 35.
Yeah, I like it. Ooh, you're still frozen up there. Find the points on the lemniscate in exercise 35. So here, infinity symbol, I love it, or lazy 8, where the tangent is horizontal. You can see that there are 4 places the tangent is horizontal, yes? So you expect 4 answers. So what would the first step be in discovering where any function has a horizontal tangent line? Find the derivative. Set it to 0, yes. So I mean, you'd have to find that whole derivative. We're not looking at 3-1. We don't care about that because we're just referencing the function, right? I want to know where its derivative is 0. So take its derivative, set it equal to 0, and hope. I don't know. I don't know if anybody, is this a homework problem?
Yeah.
Okay. Did anybody else try this problem yet? Yes? Okay, let's do this. This will be a good little example, little sample problem. Can you guys go ahead and take that guy's derivative in number 35? If you haven't done this problem yet, we're getting some homework done. So it's good motivation. Number 35, yes.
Which section?
Section 3.5. It's kind of nice. 35 and 3.5.
Oh, shoot, I didn't write that one.
I know you can't see this, which is perfect. I know, he said 40, 47 references 35, yeah, sorry. That was my fault, I forgot. Yeah, we're doing 47 with references 35, sorry. But right now, you gotta know is we're taking the derivative of that function. That's all that matters. All right, you guys think you have the first step?
Yeah.
That would be like 2x squared.
Not sure, okay.
You know what I mean?
Nope.
Okay, so it's like it's chain rule. And like your first part, your outside would be like 2x squared, and your inside would be x squared plus y squared.
Well, there won't be an x, because don't you have something to the second power, yes?
Mm-hmm.
So how do you take the derivative of that?
Stuff squared.
So it would be
2 comes down,
4
makes it 4, because there's a 2 down there already.
times x squared plus y squared.
Good. Do the first power now.
Oh,
Times x
Derivative
squared
of the
plus
inside,
y squared.
which is just, yes. Could you distribute? Oh, sure. If you wanted to. We're about to distribute everything, so it almost doesn't matter. And then on the other side, it's not too bad, yes? It's not as bad, because it's just derivative of x squared and derivative of y squared. You guys all with me? So the 2, for y squared, the 2 comes down, times y to the first, times the derivative of the inside, which is y prime. Now I just gotta FOIL the hell out of this thing, because I want to get all my y prime stuff together. Yes?
Yep. I don't want to.
This is kind of it's okay. Let's see. So I get 4x squared plus 4y squared times this
Times 2x plus 2y
equals 50x minus 50y y prime. So I could divide both sides by 2. I don't care. I get 8x cubed plus 8x squared y prime plus 8xy squared plus 8 y cubed y prime equals all this business. And actually, let me think. No, I guess it's not really a good way to do that.
It's supposed to do.
I'm sorry, what was it asking for you? The word horizontal.
That
That's
was-
right. Okay.
yeah.
I forgot what we were doing. So I'm trying to get y prime, and then I'm going to set that equal to 0, correct? Okay. Alright. Okay, so this guy's in the wrong place, yes? This guy at the end, in the wrong place, poor little dude. Walked in the room, he's like, oh shit. Who else is in the wrong place? This guy's in the wrong place. This guy's in the wrong place, right? Because that's the sign for y primes. What the hell's wrong with them? How dare they? So we got 8x squared y prime plus 8x, no, yes, 8y cubed y prime, there we go, equals, nope, plus 50y prime. Okay, so I'm going to add this over, and I'm going to subtract these two over. Equals 50x minus 8x cubed minus 8xy squared. Oh, Jeff, this is so fast. Okay. So then I can factor a y prime out and divide by stuff. And this is desperately trying to be a plus sign. Poor little guy. He's doing what he can. So, right? Factor y prime, divide by the stuff. Okay. Now, you're going to get y prime equals 50x minus 8x cubed minus 8xy squared. Jeff. It's not good if you confuse x and y. Divided by stuff. Right? Why do I write that? Because what am I going to do with this? I'm going to set it equal to
0.
And what's the only way a fraction can be 0? If the top is 0. Yeah. So I'm going to set the top equal to 0 and then hope. Right? Yes.
Just a quick question.
Yes.
Why would you set over the top equal to 0?
What's the only way a fraction can be 0, can equal 0?
Because if the top is 0.
If the top is 0.
Yeah, the bottom is 0.
If you factor y prime out, you're going to have stuff, right? Y prime times stuff. You're going to divide by stuff. And why do I not care about the stuff? Because I want to make the fraction 0, and the only way to make any fraction in the entire universe equal 0 is if the top is 0. So do I care what the bottom is? Not really. One thing about the bottom is, no, that's not even true. So no, I'm not going to say that. And, yes.
Can't there be a whole room?
I don't care.
Wouldn't it like ruin our answers though? Like if there was
Oh, it's almost not, I don't know. That could be. Are you worried about like a point can make the top and the bottom 0?
Yeah.
Okay. Well, stop worrying about that. Don't worry about it. Yes.
What about on quiz 2, number 2?
Quiz 2. What?
Yeah.
Quiz 2, number 2. Okay.
They're all different though, right?
Want me to show you?
No, Mike, what am I going to do right now? I'm going to make a problem that
everybody had, but nobody had.
Yeah.
Yeah, that.
So everybody had this problem, but
Nobody had this problem.
yeah. I don't know. I don't know. So it was something like this, right? This one?
Yeah.
Okay.
And it's like
Yeah, I know.
Is that a pie?
yes, it is.
Don't give me grief. Let me see. Wait. I want it to be a pi, yeah. Then that would be 6 pi times. Oh, so I want this to be 6. It doesn't matter. Oh, hey, Jen. Let's see. Okay. Oh, cool. Thank you. You can tell they're really rough. To be honest, I don't use them anymore.
Well, I
Wow.
usually come every 2 weeks, but I didn't make it last weekend.
By the way, this is Jenny Van den Linden, and she is the part of her job is to be the towel fairy. She's awesome. All right, you guys with me? So everybody had this problem in the quiz? So I wanted to know the equation of the tangent line at this point. Real quick, if you plug a pi in, I don't think I gave you the whole point, did I? If you plug a pi in, don't you get 6 pi times, it should be negative 3, should it? I won't do that. 6 pi times cosine pi. What is cosine pi? Negative 1. So you get negative 6 pi plus 3 pi is negative 3 pi. There you go, Jeff. You'll get it right somewhere. Okay, so on your test, you had to plug the value in to see the other part of the point, if I remember correctly. Because I need the whole point to get the equation of the line. How do we get the slope of my line? Derivative, right? What's the derivative of this piece going to be? 0, so don't worry about it. So it's 6 cosine x minus 6x sine x. Is that cool? Mm-hmm. And I'm curious about the derivative at what x value?
Pi.
Pi. So I get 6 cosine pi minus 6 pi sine pi. What is sine pi? 0. So what's cosine pi? Negative 1. So you get negative 6 is slope, blah, blah, blah. Right? Plug it in, y minus y1 or whatever. Yours were all easier because I think everybody's output should be 0. I set it up that way on purpose so it wasn't as ugly as it could have been. You're welcome. So the right answer should be like 4x minus 2 pi or 3x minus 3 pi or sine. Yes?
3.567. I got like halfway there and then got stopped.
Oh yeah, this guy. Okay.
I know it's the last problem, so it's
no, I know, and I don't mean to make you guys. When I'm doing a test, I'm most concerned about the kind of problems I will definitely put on the test. I am not going to put this problem on the test or anything like this problem. But so I already talked about the fact that this line seems to be very important.
Yeah.
Yes. You know that one point is 3 comma h. If I call this the height, h. You guys with me? And the other point is negative 5, 0. Can you figure out the slope of that line?
Oh, yeah.
Yeah, and have an h in it. Or you can call it y instead of h, because h gets a little weird, because then it sounds like f of x plus h. Is that kind of, and then you can take the derivative of this guy.
Okay.
And you already know what this, you want the slope of this to be, correct? You already know what you want the slope of that to be.
So then you just put, yeah, got it.
Yeah, okay, maybe. Don't use y either, because it's in that equation, so maybe use L or P for pole, maybe? I don't know. Whatever works, yeah.
Are we going to go through 3.6 or 3.7 today?
What do you, so 3.7 we did. 3.7 is position, velocity, acceleration.
Oh, okay.
3.6 was logarithmic derivatives we already did. Yes, okay. So when I did the x to the secant x problem, that basically finished out the new stuff. Right. Yeah. I'm trying to remember what's yes. Yes, the only homework due Wednesday is 2.8 through 3.7. What else is due Wednesday? Test 2 corrections if you want. Quiz 2 corrections. Quiz 3 corrections. Yes. If that sounds like too much, just don't do the corrections. 3.7, 2E?
Yeah. I did not like 2.7. 2.7 was not my friend.
Find the total. Oh, yeah. Okay. The total distance traveled. I think they do a really good job of explaining the idea here. When you turn, you're losing position, correct? If the train goes to Seattle and comes back, it's back to position 0.
Mm-hmm.
But did it travel 0 feet?
No.
No, it traveled a hell of a long ways. So if you find the turning points, you have to actually do the absolute value of how far it went. So they do a really good job of, in this example, of showing you how to do that with a more complicated function, I think. Well, maybe not. Maybe it's not as complicated, but still. So that would be this one. Part F, find the total distance traveled. So again, if I start here and I call this 0, and I walk 5 feet this way, and then I walk back 5 feet, I'm back to 0. My displacement would be 0. My total distance traveled would be 5 plus the absolute value of negative 5. Holy shit, yes.
What?
You said 10, which is the right answer.
No,
I
guess I'm not understanding how you would draw that thing.
You have to figure out the turning points. And how do you figure out the turning points? What happens when something turns? If I'm going up in the air and I'm about to turn, I have to first make my velocity 0, and then I can turn around, right? I don't mean like if you're going circular motion. I mean if you're going, and if you want to go back the other way, you have to come to a stop and then turn back in the other direction. Yes? Okay. So set velocity equal to 0. That'll show you all your turning points, and then you can follow the example perfectly. I am not as concerned, obviously, as that question. Try to do it in the homework, but I'm not going to ask you that question on the test. I'm not as into that question, to be honest.
What about F and H on the same? Or sorry, H and I.
F and H. Oh.
H and I.
H and I.
On the same thing.
I like F and H. F and H. Graph the position, velocity, acceleration. Oh, okay. Well, you'll know S of t from the beginning. You know V of t and you know A of t, and it has whenever it's got this little symbol, it means in your graphing calculator.
Oh. Okay.
If you don't have the symbol, it means don't do it in your graphing calculator. Do it by hand.
Okay.
And then okay, listen. Okay, this is really cool. I'm going this way. Yes. I hit my brake. What's my velocity? Which direction is my velocity? Is my velocity positive when I hit my brake? Start to slow down. Yes.
Yeah.
Which way is my acceleration going? Back. That's why I'm slowing down. If my velocity and my acceleration have the same sign, they are acting in the same direction, I am speeding up. So if I'm going negative velocity, but my acceleration is negative, I'm speeding up in the opposite direction, yes? You guys kind of with me? So when is it speeding up? Whenever the velocity and the acceleration have the same sign.
Okay. So
How
how
the
would you
shit
go
do you
about
do that? Figure out when they're equal to 0, and then on either side of that, they could change their sign, correct? Maybe. When is it slowing down if they ever have opposite signs? If my velocity is negative, but my acceleration is positive, I am slowing down, correct?
Mm-hmm.
And eventually it's going to become 0, and if my acceleration continues negative, I'm going to start going the other way.
So then how would you do that one?
Same way. So,
Set it equal to 0?
Here. This
Is
first.
what's supposed to
Look.
equal?
Set equal to 0 to start with.
Yes.
Set equal to 0 to start with. So let's look at this first thing, real quick. Because it's so easy. You took it away, Jeff. Write it down. All right. What is it? T cubed. Did my Apple Pen go to sleep? What happened? Yeah. Holy shit.
Did it die?
Did it die?
It might have died.
What kind of battery? What kind of cable do you use?
USB-C.
I have one.
Makes me so sad. Poor little guy. I forgot I have to recharge. It's like, yeah, Jeff. Do you water your plants?
Right? USB-C?
Yes. All right, let's see.
No, you can use a battery.
I can plug it into this.
Oh.
Yeah. Okay.
It's a tiny one too, so it's not going to dangle like crazy.
It's not going to dangle. All right. I could just use a pen, Jeff. Oh, I see. It's not USB on the other side. Okay. All right. Here, no worries. Look at this. I'm going to go major old school, like way back in the day.
You meet like 3 weeks ago?
I know. Okay.
So long ago.
I do, yeah. Oh, I'm okay, thanks, dude. I'm gonna give up and just go to the overhead. Did I bring any paper? Yes. What is that? Doesn't matter. What was the question again? People?
Okay.
So I was gonna write down t cubed plus damn it all. What was it, 3 point?
It's
7?
9t divided by.
No. I just want to get the idea. I'm not going to do that one. T cubed minus 9 t squared plus 24. All right, that's S, yes?
Yeah.
Okay. What's the velocity then?
18t.
What?
No, sorry.
3t squared
3t
minus
squared
18t
minus 18t plus 24.
Where's the velocity 0?
At where that equals.
Where that equals? All right, I love it. So if I divide by 3, Jeff, divide by 3, buddy. There you go. And then I factor this thing. I get t equals 4 and t equals 2, yes?
Mm-hmm.
So at 4 and 2, it changes direction. How do I know that? Because these are multiplicity 1, yes?
Okay.
Doesn't bounce. Or turn, yeah, okay. What's the acceleration?
6t.
Yes, 60.
Plus, minus 18.
Minus 18, when does that equal to 0?
When
T equals 3. I like it.
Okay.
So, for the velocity, at 2 and 4, it changes sign, and for the acceleration at 3, it changes sign, yes?
Yes.
Okay, so for the velocity, what's the sign at 0?
Positive.
Positive. What's the sign at 3 for the velocity? See what I'm doing? Isn't it 0 at 2 and 4? Didn't we figure out it's 0 at 2 and 4?
Yeah.
Okay, so now I'm just saying, what is it around those? When I plug a 3 in, what's the velocity become? So this will be, and to be really honest, I can just look at this. When I plug a 3 in, isn't this negative times positive?
Yeah.
So that's negative in here. And when I plug a 5 in, I get positive times positive. It's positive over here. Let me stop for a minute. You guys with me? So it's going away from me, coming back to me, going away from me. So acceleration goes to 0 at 3. Is that cool? It's a freaking straight line. If I plug in a number below 3, if I plug in a 0, isn't this negative?
Yeah.
If I plug in a 4, isn't this positive?
Mm-hmm.
Yes. So can somebody tell me, where do the acceleration and the velocity have the same sign?
At
2 to 3. So it's speeding up between 2 and 3.
And from 4 on.
And from 4 to infinity. That's where it's speeding up. You guys see that? It's that straightforward. Just where do they have the same sign? And this is a really good visual to give yourself.
And then the other
if
one.
you figure out where it goes through 0, it's potentially changing sign. It might turn like a multiplicity even. It might turn, in which case it stays the same sign, but your little number line will capture that. And then you can very quickly see, where does it have the same sign? Now, where is it slowing down from negative infinity to 2? Do you guys see that? Because it has different signs. The velocity is positive, the acceleration is negative, therefore it's slowing down. You guys kind of with me?
And then for the.
That's like velocity positive, acceleration negative, so I'm slowing down, and then I go circle back. Ah! Okay. One of these times I'm going to trip over and kill myself. Be neat day.
I hope not.
Me too. So it's good to hear.
So
Thankfully, nobody out there went. Okay. All right. Anything else? I do have one of these for some reason. Have you guys ever seen this before?
Yeah. I have one of those.
Can't see what I'm talking about. Somehow this is going to relate to section 3.9.
Can you do the next problem again?
Wait, I'm going to do the Mona Lisa, okay?
Oh gosh.
Okay, can you start to see it coming together?
Sure.
No, I'm like Brian Regan, I can do.
I made stairs.
Okay. So how many of you guys have never seen this? Anybody never saw this before? This is before we had Game Boys and shit. We had this, kids. And when we got, look, watch this advanced, ooh. That's the upgrade. All right, sorry. Oh yeah, I remember those. They were sticky. Yeah. That's like the. That's like what I got for Christmas, like the poor kids etch a sketch.
Yeah.
All right. Anything else? Did I miss a question? I think.
3.6.
Don't worry about etch a sketch. It'll come later. Which one, sorry?
3.645. Looks. I'm looking at the what I wrote down. It looks pretty simple, but I had a problem with it. I don't know why. Oh, never mind. We know that now.
Yep.
Never mind.
Oh. It's still a good question. Well, that looks weird. So use logarithmic differentiation to find this. So if I take the natural log of both sides,
Okay.
can't I simplify this a lot? Because I know what the natural log of A times B is. What's the natural log of A times B?
Natural
log of
A plus
the natural log of B, because logs are just powers. What do I do with the powers of like bases when I multiply them? I add the powers. So the natural log of A times B is the natural log of A plus the natural log of B. I add the powers. So every rule of logarithms is the same as a rule of powers. Because that's all frickin' logs are, powers. So if I take the natural log of both sides, it'll be the natural log of x squared plus 2 squared plus the natural log of x to the 4 plus 4 to the 4th. Then what happens to the square and the 4th power? They come down. So this problem becomes a lot easier. Or different, at least. So to be really honest, it's not that bad the way it is. Do you guys agree?
No.
But they want you to use logarithmic differentiation, so too bad if you didn't want to.
The next.
But like number 47, for example, do you understand how 47 is a little bit sucky? Isn't that a chain rule that also involves quotient? So if you rewrite that as that to the 1/2 power, take a natural log, you break it down, it becomes easy as shit.
Yeah. 50 and 55 aren't as easy though.
50 is like the one we did earlier with the x secant x, yeah.
Yeah, because then
so those two
are
should be
going to bring
straightforward.
the 1 divided by x down.
Yes.
Yeah.
I like it.
And then.
Those are more like your classical uses of logarithmic differentiation, yeah. Look at this guy. But if you do a logarithm, it'll be natural log of e to the negative x plus natural log of cosine squared x minus natural log of x squared plus x plus 1. And then the 2 can come down, and then what's the natural log of e to the negative x? What does natural log and e do to each other?
They cancel each other.
So what's natural log of e to the negative x?
Negative
x. That kicks ass. Okay. I'm so tired. I'm so fine if we stop. But if you have questions, I'm fine with that too, because class is not over. I did not say that to make you feel like you have to leave. I'm just telling you, I'm okay if we do. Does anyone have any other questions?
Why put number 48 on that one?
Yeah, so if you take a natural log, why this thing can't focus? It'll be 1/2 natural log of x plus x squared minus x plus 2/3 natural log of x plus 1. So let's look at that. Some of you guys are like, should I stay and watch this? Or so watch this. Do y'all agree this would be a kind of a gross triple prodigal with chains and shit in it? So if I take the natural log of both sides, is everybody cool with this? Natural log of square root of x would be natural log of x to the 1/2, and then 1/2 can come out. And ln of e to shit is just shit. Okay. And then plus 2/3 ln of, where'd it go? X plus 1. So what's the derivative of ln x?
1 over x.
I'll do this side. Yeah, so it'll be 1 over 2x because you already had a 1 over 2 there. What's the derivative of x squared? Oh, what's the derivative of x? Oh, what's the derivative of ln of x plus 1?
1 over x plus 1.
Yeah. And then you just multiply y up, and what was y? Well, y was all that crap, and then you're done. You're done, kids. You're done, so. So that's the power of natural logarithmic differentiation, because all the properties of logs allow you to break it up so much that each piece becomes pretty easy. Maybe. Anybody went to the Math Study Center for the first time anytime recently? Anybody went to? You did? For the first time? Well, anybody go to the Math Science Center a lot? Anybody? Okay. At the end of the semester, I'm able to get a list of all my students who actually went for tutoring, just to let you know. I might use that to, like, you know, if you got an 89.7 in my group today, little effort grade,